Alright guys, in this video we'll be checking out some questions on variation of parameters, and we have our question number 1 to be there. Now before this video, it is advisable to have the knowledge of how to look for the auxiliary equation of a differential equation and how to look for the complementary function or the homogeneous solution of a given differential equation. So you should have the knowledge of that before watching this particular video. Now we have our yc or yh to be c1 e raised to power x plus c2 x e raised to power x. Then to look for our Wronskian, we have our Wronskian to be that the coefficient of c1 and coefficient of c2, then we differentiated their coefficients, so we have our Wronskian to be e raised to power 2x. Then we look for w1. Now looking for w1, it is always constant to have to put 0 and 1 if it is a 3 by 3 matrix. That is, if we have a three different functions or 3 different variables in our complementary solution, then you'll be having it to be 0 0 1. But since it is just 2 that we have, you have to put the 0 1 there. Then you repeat x e raised to power x and s e raised to power x plus e raised to power x. Then that's for w1. Then for w2, we take the left hand side of our Wronskian, then we have it to be e raised to power x, e raised to power s, 0 and 1 repeated. Now we move to c1 to look for our c1. C1 is given as w1 over w times rx. Rx is the solution of the non-homogeneous equation, that is e raised to power x over x. That's our rx. So we have our c2. Our c2 is also w2 over w times rx. So when we solve for our c1, we have our c1 to be x, we have our c2 to be ln x. Then don't forget, from our homogeneous solution we have c1, so we insert the value for c1 and the value for c2. So we have our homogeneous solution to be minus x e raised to power x plus x e raised to power s ln x. Then we add everything, we bring everything together to get our particular solution. Thank you. Alright, so we move to example 2. Example 2 says that y prime prime plus y equals to sec cube x. Then our homogeneous solution is given as a e raised to power ix plus b e raised to power minus ix. Now if you recall from complex analysis, if you've not watched my videos on complex analysis, kindly do so. You see the videos there. E raised to power ix and e raised to power minus ix will give us cos x and sin x respectively. Then we look for our Wronskian. Our Wronskian is 1, that is cos x, that's cos squared x plus sin squared x, that's 1. So our w1 will be 0 minus sin x, that's minus sin x. W2 will be cos x. Then we look for our a. Now our a is given as integral of minus sin x over w, and our w is given as 1 times sec cube x. Don't forget that sec cube x can still be written as 1 over cos cube x. Then we have it to be sin x over cos cube x. Then we solve by u substitution by saying u equals to cos x. Then our final solution is 1 over 2 cos squared x. Then to solve for b, now we apply the same thing. We have it to be cos x times sec cube x, and we have it to be 1 over cos squared x, because sec cube x is 1 over cos squared x. So cos x cancels out cos x, then we have it to be sec squared x, and when you integrate sec squared x, you have it to be tan x. So our homogeneous solution therefore becomes, we have our a already and we have our b, so we take it back to equation 3. Then we have our final answer to be 1 over 2 cos x plus sin x tan x. Then our particular solution now becomes a cos x plus b sin x plus 1 over 2 cos x plus sin x tan x. Alright, so we move to example 3. Example 3 says the squared minus 3d plus 2 all y equals to 1 over 1 plus e minus x. So we have a homogeneous solution to be aex plus be2x. Then our Wronskian to be e raised to power 3x. Our w1 to be 0, 1 e raised to power 2x, 2 e raised to power 2x. w2 to be ex, 0, 1. We have it to be equals to e raised to power x. Then we proceed and solve for the value for a. A then becomes minus e raised to power 2x over e raised to power 3x times rx, where rx is equals to 1 over 1 plus e raised to power minus x. So when we simplify, we have it to be 1 over, we expand the denominator. After expanding the denominator, you factorize out, then you will have it to be ln e raised to power x plus 1. Now the negative sign of, there is a negative sign there, but it is ignored based on the fact that we introduce what, an absolute value. So b is given as minus 1 plus e minus x minus ln e raised to power x plus 1. Then that is that for b. So we bring them back to our homogeneous solution. So we simplify further and have that. Then our particular solution is given as that. So just check through the videos, check through the pictures and comprehend. Thank you.